2, it says determine whether the correspondence is a function. So the way that it works is you have a relation, and then you have a function, and then the function is 1-to-1, and this is by 1x to 1y, or it's by another way to see is the vertical line test. And then you have not a function. So what I mean by 1-to-1, in this case, this domain and this range are 1-to-1. So if I had an ordered pair, there's so many different representations of functions. But domain is x, range is y. So when we're looking at our order pairs here, I have -1, 3, 2, 3, and then 7, 3. This defines itself as a function because we have 1x to 1y. That means an x has to go to 1y. You can have x's going to more than 1y. So it would have to be the same type. So suppose we say in this case, instead of 2, so this is a function, right? We're gonna 1-to-1, this is a function. There's a demonstration. If I have 3 goes to 2 and 4 goes to 9, this is a function. But if I have this situation of where my 3 is going to 2 and 9, and this is not a function. And we call this mapping. So your x is the domain, your y is the range, x domain, y is the range. So in this case, your x is going to the same y, but they're different x's. So Detroit is your x, y is going to be the Lions, the Tigers, and the Pistons. So Detroit is trying to go to the Lions, the Tigers, and the Pistons at the same time. Pretend that you're a resident in Detroit. Can you go to a Lions game, a Tigers game, and a Pistons game all at the same time? No. So that's why it's not a function. It's the same thing with New York. New York being the domain, and the range being the Knicks, the Mets, and the Giants. Think of yourself as an audience member. You're a New Yorker. Can you go to a Knicks game, a Mets game, and a Giants game at the same time on the same day physically? No. So is the correspondence a function? It's not. Outputs. Here's the vocabulary that we need. We have x and we have y. And x is also known as the domain, the x-axis, and the input. The y is the range, the y-axis, and the output. So you have an input that becomes an output, and it's based on the function. When you have f of x, we indicate that that's going to equal y. This is the x value, so it indicates some value, whatever's given to you. In this case, we have f of x equals 3x squared minus 4x, and then it has f of 0. This is basically stating that x is equal to 0, and we want to know what our y is, or f of x. So f of 0 equals 3 times 0 squared minus 4 times 0. So then we have 0 minus 0. F of 0 is 0. I'll put that in there. F of -1. So it's 3 times -1. Put the -1 in parentheses, and then 4 times -1. we're going to start right here. And with the first term, it's 3 times 1 because 1 squared is 1. So then we get 3. And then the second term, it's negative 4 times negative 1. So that becomes positive 4. So then we get 3 plus 4 equals 7. 3 times 2 squared minus 4 times 2. So we do this, 3 times 4 minus 8, 12 minus 8, and then get 4. So f of 2 is 4. A, where we have f of 1, absolute value of 1 plus 2, so that's 1 plus 2. So f of 1 equals 3. And you have f of 3 equals absolute value of 3 plus 2. So I get 3 plus 2 equals 5. That's f of 3. And then this next one is unique because you can't take the absolute value of an entire expression. So it's going to be f of a plus 1 equals the absolute value, a minus 2. Is it minus 2? So then it's going to be absolute value of a minus 2 plus 2. This entire thing is your answer. So when we put it in, we're going to use absolute value a minus 2. And then arrow to the right, because you want to be outside the absolute value, and then add the plus 2. Oops, let's say plus 2. Okay, so now we have a word number 5. It says, what does it say? A function as given by as equals 0.328s plus 51 can be used to estimate the average number of employees of a company in the years of 1981 to 2009. Let as be the average of the employee and s be the number of years since 1981. That is, s equals 0 for 1981 and 9 equals 1990. What was the average age of the employees in 2003 and 2009? So let me just work this out for you. So basically, we have to find like the numerical equivalent of 2003. And in this case, since 1990 is 1990 will be 9. 2003 is going to be 22. And then we're going to substitute into the equation that's given. As equals 0.328 times s plus 51. So we're substituting this 22 where the s is. It should be x, but a and x. We're going to use s and x interchangeably. We're going to substitute. We're going to say that they equal each other right now. So then you get 0.328 times 22 equals 51. You get a of s equals 58.216. You're going to round. And when this number is below 5, you keep the 58. You keep what's before the decimal on the left. So that's the average age of employees in year 2003 are 58 years old. For the next one, 2009 is going to be equivalent to 28. That's what we're substituting. So I have a of s equals 0.328 times 28 plus 51. We get 60.18. And when we round, this 18 is below 5. So we're going to keep everything to the left of the decimal. And this is going to be 60. So the average age is 60 in 2006. 6, I believe, you are graphing. So when we graph, we want to make sure that what we see is the points that we're using for the graph. So f of x equals negative 3x. Please recall that when we say f of x, we're saying that we're looking for the y value as well. So when you choose the points, we like to choose simple points. So x and then f of x, again, f of x is equal to y. If we go in order, it would be something like 0 and negative 1. You only need 2 points to make a line. So negative 3 times 0 equals 0. Negative 3 times negative 1 equals 3. If you look at the graph, that's what was plotted. Fill out the table, and then we're going to graph the absolute value. When we graph, you want to graph the vertex first. So let's go ahead and fill out the table. So when x is negative 2, you're going to substitute into the formula. Negative 1 minus absolute value of negative 2. Negative 1 minus 2. This right here, that negative 2 became a 2. That negative is from the operation. So then you get negative 3. So f of x equals negative 3. X equals negative 1. We substitute it. Negative 1 minus absolute value of negative 1. 1 minus 1 equals negative 2. X equals 0. Negative 1 minus absolute value of 0 is just 1 minus 0, which is negative 1. F of x equals negative 1. And then x equals 1. Substitute it. Negative x minus absolute value of negative 1. The negative 1 just stays 1. Again, those operations are negative. That's why we keep on bringing them down to the next line. So then negative 1 minus negative 1 is negative 2. F of x equals negative 2. And then x equals 2. Negative 1 minus absolute value of 2. 1 minus 2 is negative 3. So this function is going to be a vertex function. It's going to go like that. You know that it's going to be upside down when you use Desmos. So when I graphed it, here's what I chose. You go to the plane, and then it gives you the V, not the U, but the V. You want to do the vertex first. The vertex is the center point. In this case, it's going to be 0, negative 1, and then choose a second point. I chose 1, negative 2. And I got these points from the work, and they're also the same points that are on the table there. All right, so we're looking at number 8. When we look at number 8, we're going to go ahead and use Desmos, and whatever the function is, g of x, it doesn't matter. You just put in y. Just make everything y and x when you're in Desmos, or you can just put in the absolute value part, like everything to the right of the equal sign. That'll also give you the same function. So in this case, you're just matching the graph. The graph that we see in Desmos has the absolute value, which is the v, and it touches the x-axis, and that resembles graph D. This is another one like absolute. This graph is going to require 3 points for this graph. So we can just type it in because we know that's going to be part 2. So it's x to the 3rd plus 6. So when I graph this, I want to graph the x-intercept. That's going to be right here at 0, 6. And then a point to the right and a point to the left. We've been using -1. So let's see. I think -1 will work.